Is there life on Jupiter's ocean moon, Europa? Europa has fascinated space enthusiasts for decades, since scientists determined there's a global ocean of water beneath the moon's icy outer crust. On June 24, 2020, NASA scientists announced new research that supports the idea that Europa's ocean is habitable. They said this underground ocean is likely similar in many ways to the open-air oceans on Earth. Europa is one of the largest moons in the solar system, with a diameter of 1,926 miles or 3,100 kilometers, just a little less than Earth's moon. While the subsurface ocean is relatively warm, exact temperature not known yet. On the almost airless surface of Europa, the temperatures are always a bitter minus 256 degrees Fahrenheit, or minus 160 degrees Celsius or lower. The fascinating results were presented at the Goldschmidt Conference. First, the findings support what scientists had predicted about the composition of the ocean, as planetary scientist and lead researcher Mohit Malwani Daswani explained in a statement. They were able to model the composition and physical properties of the core, silicate layer, and ocean. They found that different minerals lose water and volatiles at different depths and temperatures. They added up these volatiles that are estimated to have been lost from the interior and found that they are consistent with the current ocean's predicted mass, meaning that they are probably present in the ocean. To reach this conclusion, the researchers modeled geochemical reservoirs within the interior of Europa using data from the old Galileo mission. The results are significant since they show that oceans like the one on Europa can be formed by metamorphism, that is, by a change of minerals or a distinct arrangement of minerals, a change in what geologists call texture, in pre-existing rocks without the protolith melting into liquid magma. On Europa, heating and increased pressure caused by early radioactive decay or later subsurface tidal movement would have caused a breakdown of water-containing minerals. Trapped water would be released and Europa's underground ocean would be born. So what about habitability? The study also found that Europa's ocean would have been mildly acidic at first, with high concentrations of carbon dioxide, calcium, and sulfate. But over time, it became chloride-rich, resembling oceans on Earth. Seawater on Earth contains 1.94% chloride. According to Daswani, indeed, it was thought that this ocean could be still rather sulfuric, but their simulations, coupled with data from the Hubble Space Telescope showing chloride on Europa's surface, suggest that the water most likely became chloride-rich. In other words, its composition became more like oceans on Earth. Hence, they believe that this ocean could be quite habitable for life. Another interesting possibility is that volcanic vents on the seafloor of Europa's ocean might have contributed to the process of waters becoming chloride-rich. That would be exciting, since such vents on Earth provide heat and nutrients to a wide variety of life in our world's deep oceans. The Cassini spacecraft has already found evidence for such vents on the seafloor of Saturn's moon Enceladus, which also has a global ocean beneath its icy crust. These are other energy sources that would be necessary for life to evolve and thrive in an underground ocean, a dark and sunless environment. As Steve Moises, professor of geology at the University of Colorado Boulder, noted, a long-standing question over whether a cloaked ocean world like Europa could be habitable boils down to whether it can sustain a flow of electrons which might provide the energy to power life. What remains unclear is whether such icy moons could ever generate enough heat to melt rock. Certainly, interesting chemistry takes place within these bodies. But what reliable flow of electrons could be used by alien life to power itself in cold, dark depths? A key aspect that makes a world habitable is an intrinsic ability to maintain these chemical disequilibria. Arguably, icy moons lack this ability, so this needs to be tested on any future mission to Europa. The results of the new study are tantalizing to say the least, but more work needs to be done. How much chloride is really in Europa's ocean? As mentioned in a June 25, 2020 article on Centauri Dreams, A paper from 2019 stated the following about sodium chloride on Europa. The presence of sodium chloride on Europa has important implications for our understanding of internal chemistry and its geochemical evolution through time. Whereas aqueous differentiation of chondritic material and long-term leaching from a chondritic seafloor can result in a system rich in sulfates, more extensive hydrothermal circulation, as on Earth, may lead to a sodium chloride-rich ocean. The plume chemistry of Enceladus, which is perhaps the best analog to Europa, suggests a sodium chloride-dominated ocean and a hydrothermally active seafloor. However, the compositional relationship between Europa's ocean and its indigenous material is unknown, and the surface may simply represent the end result of a compositional stratification within the ice shell. Regardless of whether the observed sodium chloride directly relates to the ocean composition, its presence warrants a re-evaluation of our understanding of geochemistry in Europa. Scientists can learn more about Europa's ocean by modeling, but obtaining solid evidence will require actually sending a mission there. Fortunately, NASA's Europa Clipper mission is set to do just that, scheduled to launch in 2023. There is also growing evidence for water vapor plumes on Europa, similar to those on Saturn's moon Enceladus. If they are there, Europa's Clipper could fly through them just as Cassini did in Enceladus, and sample the vapor for analysis. If connected to the ocean, as Enceladus are thought to be, that would provide valuable clues as to the conditions in Europa ocean and maybe even evidence of life itself. The latest analysis of Europa's ocean is tantalizing, but we will know a lot more after Europa Clipper and ESA's Jupiter Icy Moon Explorer, or JUICE, mission. So now let us discuss, can we expect to find life on Mars? Well, you know what? That actually sounds like another topic we should save for another video here on Discover Zen.